Hi everyone. Yeah, it's a little bit late, but I'll try to be a little bit quick but effective. So the topic here is securing cloud, especially for infrastructure, yeah? And also thinking about risks and compliance in this cloud infrastructure. I'm Sandeep Tripathi. I work as an IT solution designer at Daimler. So I'm not directly working in security area, but while architecting with the idea of secure by design, I'm very close to security topics. Daimler Truck is a commercial vehicle manufacturing company. It has around 100,000 employees around the world, and the headquarters is in Leinfelden, Echterdingen in Stuttgart. So a little bit about myself. I'm a cloud professional. I have a degree in software engineering. I've been involved in a lot of voluntary works, especially for AWS, and also I'm a community builder for container technology. So for today, the plan is to know a little bit about best practices for creating infrastructure in cloud, to think about IT risks in cloud environment, and to understand how can we think of compliance while creating different architectures. So how do you start with creating an architecture? First, you'll get a use case from a business, for example, or department. They will say, these are the requirements in a non-technical way. Then you convert this into some technical quality attributes, as the IT architect people call it. Think about something like performance, or scalability, or confidentiality, yeah? Or integrity, those kind of quality attributes. And those quality attributes has to be then transformed into the components that you will be using in the cloud environment. So it can be, the requirement can be such that the user will say, I'll be using AWS because my team is familiar with AWS, or they can say they will use Azure or GCP. In Daimler Truck, it's more of a Azure, AWS, and Oracle. There is no GCP, but just for completeness, I have written there at GCP. And also in cloud, when you are deploying, you have to choose how will you deploy your software. Yeah? So I'll talk about two particular ones, container and serverless. Assuming this use case requires some microservice as a design pattern. Yeah. And also I'll go into the unique risk when you are trying to deploy in the cloud. So here's one small architecture. It's not a complete architecture, but a small architecture where I'll be trying to talk a little bit about defense in depth. Yeah. So for architecture, first, the deployment will happen from there are two different kind of deployments. Yeah? One is the infrastructure itself has to be deployed, and second is then you will deploy your software in the infrastructure that has been deployed. So for both, the best practice or a good practice is to use infrastructure as code. So you write some kind of code which you can have a version of, and then update the version as per you deploy your infrastructure or the software. So here is more about the infrastructure than software. So for infrastructure as code, one very common tool that can be used is Terraform. It's also being used at Daimler Truck. But you can use something like Ansible as well, or you can use the cloud native infrastructure as code tools like CloudFormation for AWS. Yeah? And then after here for the versioning and also for the version control system, GitHub has been used. Yeah, GitHub Action is part of GitHub. And whenever you write your code in Terraform, that is being checked at SNCC. But you can also use dependable that's native to the GitHub. So with this, one of the best practices that can be achieved is automation. With infrastructure as code and using CI/CD, you can automate the whole process. Yeah. So at the end there, you can see this word defense in depth. Yeah. So whenever we are trying to create a secure architecture, we want to think about secure application, secure host, meaning it could be your Kubernetes cluster, or it could be virtual machine, or anything there you can run your code, some kind of compute. Then you can think of security of the network. Here in this architecture, you don't see a lot of networking things going on, but at the background, there will be network. Yeah, you can think VPC as one of the cloud native networking component for AWS. But to make it secure, you also need to have some kind of intrusion prevention system, yeah? So that external people cannot come into your network. Then another thing for network, you can have firewall. You can have firewall rules. So say only people from certain region can come into your infrastructure. Yeah, that should be there. And also one of the best practices that's being used in Daimler Truck is to use intra-ID as the identity provider. So if you are not the user in intra-ID itself, you won't have access to the network. And since you don't have access to the network, you won't be able to deploy anything in the cloud or use the cloud resources. Yeah? So that's a little bit about the network part. Then after the host is here in this case is the ECS in Amazon, but it can be anything where you can run your code, any kind of compute, serverless, virtual machine, Kubernetes cluster, or the ECS. ECS is just a managed version of Kubernetes cluster provided by AWS. But you can also run EKS, which is more of a Kubernetes-based host. So there also you have to think about securing this host. Yeah? One thing which was already mentioned was secret management. Whenever you have the cluster, then you'll have some kind of secrets associated with the cluster. Here, you can't see a database, but the application will, of course, interact with database. The database will have their APIs. It will have their connection strings. That also needs to go into the secrets management. For example, it can be Vault if you are more Microsoft native, or it can be AWS Secret Manager if you want to be cloud native. Yeah. And also, for networking part, there is this endpoint, which is a private endpoint, meaning all your data will travel only through the AWS backbone. The same principle applies also to the Azure. They also have this kind of private endpoint where the data will not leave the backbone of that particular cloud provider. Yeah. Then after here, the host is a AWS Fargate. So you need to have an image to run your application. So the image has to be pulled from some kind of registry. In this example, it's being pulled from the ECR, which is the registry for AWS. This also can be non-cloud native registry, for example, Docker Hub. Yeah. But it's always advisable to use native things, so you are more safer, and it integrates well. Another thing you have to understand in terms of security is which region are you deploying your infrastructure and code and your application, because there will be laws and there will be legalities that's based on the region you are operating in. Yeah. For example, if you are in Europe, you have this GDPR, which is not in if you are working in America, yeah, USA. Yeah, and also for network part, there are this private subnet, which are more secure than the public subnet, which cannot be accessed by people outside of the network. Yeah. Then I will just go with the next architecture. So this one is also a valid architecture. Yeah, but there are some few things missing. And this is one of the reference architecture from the AWS itself. And it's very famous in any audit-based companies where they have to do a lot of auditing. Yeah? So, and this follows this architecture pattern called CQRS, Command Query Responsibility Segregation. Meaning there will be people who have access to database, who can write on the database, and there will be people who can only read from the database. And that's been segregated. And as per compute here, instead of Kubernetes here, Lambda function is being used. You can deploy your application code in the Lambda itself, and you can run the application there. And it will integrate with the database. And everything that you did in the previous architecture should be done here as well. Firewall, intrusion prevention, networking, anything that has to do with networking, yeah. And one extra thing that has to be done here is the API management, because Lambda works based on API, and also Lambda being a serverless has a limit, rate limit. After a certain amount of requests, which is 1,000 for Lambda, I guess, then you cannot have a concurrent request after 1,000th request. Yeah? So in terms of request management, you have to do API management and the rate limiting for the API itself. And one extra thing about this particular architecture is you can see the DynamoDB streams. DynamoDB streams are more of a records that will tell you about the changes, yeah, in terms of crude operations. Those changes can be used by the auditors to see who has changed particular thing in the database at what time, and so on. So thinking about risk in cloud, we should first start with threat modeling. If you have an architecture, you have a use case. From the use case, you came up with the architecture. From architecture, you have to do a threat modeling. Meaning, for each component, there will be some kind of security threats that you have to sit down and figure out. And these security threats can be always associated with some kind of compliance framework. Yeah. For example, if you have ISO 27001 that you have to be compliant with, then you can think of the security controls based on that. And also, one thing you have to understand is being compliant is not being secure. You can be compliant with particular framework, but maybe you will not be secure. That you have to keep in mind. And what's the risk in cloud? Especially, we have multi-cloud, we have SaaS, we have a lot of things going on. There, managing the compliance and security is much more complex. Because if you are running things in Azure and AWS for one particular deployment, then the complexity of compliance is much higher. Also, the more the surface area, more the possibility of attack. Yeah? The more components you use, the more providers you use, your surface area will increase, and attackers can use that to attack you. Yeah? And the risk is about data governance. Based on the industry you are working in, there will be some kind of data classification that you have to go through. For example, finance is more regulated industry, and the data governance is much stricter in finance sector than in, say, automotive. But in automotive as well, there will be certain kind of sections in automotive manufacturing company that are more regulated than the others. And shadow IT is more of a, there are different cloud accounts that people are playing around with. They are deploying things. They are using it to run their own things with the central IT not knowing who is doing what. Yeah. So that can be also a challenge in cloud scenario. So when you think about compliance, we should think in terms of governance, risk, and compliance. Governance is more of a legal thing. This is something you cannot skip. And this is mostly legalities, the law of the country, so to say, yeah? Law, regulation, and so on. And there are standards that are there to tell you about this governance. For example, ISO or NIST and such things. And there can be policies, yeah? In cloud, you will always have this approach where you use policy as code and try to implement these policies. And these policies can be actual real policies, like rules and policies that are created by the government or the regulators. So that's the technical implementation of the policies. Yeah? And this technical implementation is also called policy. And that you can do as a code and use for governance. If you go into the risk side, like I said, you want to do threat modeling for each component in the cloud architecture and come up with the risks that you want to prioritize, because resources are less. There is cost associated with every security control that you will use. So you want to figure out which things you want to prioritize. And for that, risk analysis is a must. And in terms of compliance, there are the rules given by the government from the country, from the state. Then you implemented the security control. Now you have to be able to tell you implemented it well. And it works as defined. So then comes the compliance part. Yeah? There you can think about threat landscape. Yeah? What are the threats associated with your architecture in itself? And also auditing. So for the auditor, you should be able to say, this thing is working, and this thing is working because of this and this. Yeah? There should be a way to take an example of database. If you have a database and only admin can do the control plane level stuff, and only the database engineer can do the data level data plane level stuff, then that should be segregated. And you should be able to show the auditor that it works. Yeah. And yeah, of course, the reporting, internal reporting, you are reporting to your C-level people, the management and all, and you are reporting it for the auditors, and you are reporting it to the legal entities of the country. Yeah. And of course, you are reporting it to your customer as well. If you are not SOC compliant, yeah, if you are a provider and you are not SOC compliant, then maybe the bigger concerns, yeah, they might not use your product. So what trends are there now in security, especially in terms of security architecture? There is always a trend to have a unified security posture. Even though you are using Azure, AWS, and Google Cloud at once, there should be a way of looking into one dashboard. So from this one dashboard, you should be able to say things are going right. Yeah? Data hygiene and privacy, because you should know what kind of data is running in what services. What applications are using financial data, what applications are using health data, what applications are using just some logs that are of no use. And with the help of classification, this can be achieved. And also, there are AI-specific safeguards. Like one, AI is being used for governing your infrastructure. Second, AI is also used for application itself. So the practice is a little bit different for data analytics when it's a infrastructure itself, and it's a little bit different when it's a application running in the infrastructure. Yeah? And next trend is the resilience and response. If you are having your resources in cloud, then you have an opportunity to have able to create these resources in multiple availability zones. You have ability to create it in multiple regions. So you are resilient, and also you also have an opportunity to have a failover. If your service is not running, if your particular microservice is not running, you can failover to the microservice if you have implemented that. Yeah. And for response, if there is some kind of incident, there should be a way of responding this incident. And it should be done, everything should, if possible, be done in a unified way. So for incident response, I should not be looking into different reports, different dashboards, rather in a single dashboard. And I should know there is some kind of threat. And I should be able to say and respond to that particular threat. So takeaway, yeah, multi-cloud design is quite common these days. For security and compliance, deployment can be done in a serverless fashion or a container fashion, but there will always be a security concern that you have to keep in mind. We have to also think about securing AI workload, yeah, and also use AI for the governance of the infrastructure itself. And lastly, the governance, whenever possible, should be unified. Yeah, thank you, and I'm open for any question.